All right, so for this question, we've got this thermodynamic data for the boiling of ethanol. So the reaction we're doing, we're taking ethanol in the liquid phase and going to ethanol in the gas phase. That's an equilibrium. So our equilibrium, to find that temperature of equilibrium of essentially when something switches from being spontaneous to non-spontaneous, that equation is temperature equals delta H divided by delta S. So we have delta H values, we have entropy values, we have to find that change in delta H, enthalpy, and our change in entropy using a summation calculation. So delta H equals, well, I've got 1 mole of ethanol as a product in the gas phase, and that is minus 235.1 kilojoules per mole. Minus, well, I've got 1 mole of ethanol in the liquid phase, and that delta H is minus 277.7 kilojoules per mole. Coefficient of 1, a molar coefficient of 1, because it's 1 mole of ethanol liquid goes to 1 mole of ethanol gas, right? For the entropy, same calculation. Entropy equals, well, I've got 1 mole and my product is 282.6 joules mole Kelvin, minus I have 1 mole of my reactant, and that entropy is 160.6 joules mole Kelvin. So do both of those calculations, and I think I get like 122 joules per Kelvin for entropy, and my enthalpy ends up being 42.6 kilojoules. All right, so here, some of you made a mistake right here, and some of you took these two numbers and plugged those right into temperature equals delta H divided by delta S, but our units of energy are different. I have joules for entropy, and I have kilojoules for enthalpy. So I need to convert those units to be the same. So let's just convert entropy into kilojoules. All right, there are 1,000 joules in 1 kilojoule. So I've got 0.122 kilojoules per Kelvin. Now I can find my temperature, right? 42.6 kilojoules divided by 0.122 kilojoules per Kelvin. And that's why I really stressed this point right here, degrees Celsius, because the first temperature we find is in Kelvin. The first temperature we find is about 349.18 Kelvin. So to find that in Celsius, we know degrees Celsius equals Kelvin minus 273. So for our degrees Celsius equals, well, my Kelvin temperature, 349.1 minus 273.15, if you want to be super technical about that. And we get a boiling point that seems a little bit more reasonable now that we're in the Celsius range, right? I get a boiling point of like 76 degrees Celsius for that. So a little bit tricky there, in that instead of asking for Kelvin, which is the first temperature you get, right, it asked for degrees Celsius. So we had to do one final conversion going from Kelvin to degrees Celsius. The other conversion was the unit conversion on energy, right? We had to convert kilojoules, right? Joules, we want those to be the same units as well. If we subtract, there would be like a, you want to put 20, if you want to put 76.0, that makes you feel better for significant figures. So any questions on that? Yeah, Colin. I mean, there should be 2 decimal places when we subtract, but I'm not super worried about the significant figures here. I was more worried about delta H, delta S calculations, and then the temperature calculation. Any other questions on that? All right.